Alright, so here we go. This is 1.6C, College Algebra, page 138. We're going to start with the composition of functions. In that first paragraph, kind of gives you an idea of what a composition of a function is. It's basically the function of a function. So, if you look at your taxes, and that's the example they give here. Most of you don't pay taxes yet, but I'm going to use that as an example. First of all, they need to know how much money you make. So that's a dollar sign. Let's make a new dollar sign. A dollar sign. So, money made. And then the government lets you do things like if you give money to the church, etc., they let you subtract that. So let's put subtract your donations. And it's a lot more complicated than this, but let's just do that. And this is then what they call your adjusted income. So this is how much money you actually made. So let's say, for instance, that you made $100 and you gave 25 to the church, and that left you with 75. So they say, okay, that's the amount of money you're going to pay taxes on. And then after you pay taxes on that, they're going to be interested in you paying state taxes. Now, Alaska doesn't pay state taxes, but other states that do is going to depend on this amount right here. So you went through this and got that amount here. Now we're going to take this amount, the $75, and plug it into the state. So we've taken one function and we've put it into another function to find out how much money you have to pay in state taxes. So it's like I said, it's function of a function is basically what we're looking at. So if you look on the bottom of page 139, they give you that example there as far as the way this works. So we've done this before. They have f and then that little circle g, and they put that times x, or the function of x, and then that actually means the function of g. So the function of g of x is what that actually is. So let's go to an example 5 on page 140. They give us f of x, and they say that equals 2x minus 5. They give you g of x, and they say that that is x squared minus 3x plus 8. And they want us to find f composite g of x. So that is, again, this here. So we're going to take f of g of x. Now if you remember in previous courses, we started with the g of x first, and then we went from there. So f of x is 2x minus 5, g of x is x squared minus 3x plus 8. So what we're going to do is we're going to write the f, and then we're going to write g of x. X squared minus 3x plus 8. So we're taking this right here and replacing g of x with that. Okay, now this is what we're going to plug in for here. So f of x squared minus 3x plus 8. So now we're going to take our f of x, and instead of putting in an x there like we have here, whenever we see an x, we're going to put this in its place. So we're going to write this as, let me erase this f here, or scribble it out. We're going to have 2 times x squared minus 3x plus 8 minus 5. So all we did is took this and put it in place of x here and ended up with this whole thing here. And your job then is to distribute and get 2x squared minus 6x plus 16 minus 5, and that will turn into 11, and you will be done. Now when we have g composite x of x, it's basically the same thing, very similar, only we're going to get g f of x, like that. So what we're going to do is we're going to kind of go backwards. We're going to take our f of x here, and whenever we see this, so we're going to take this, and whenever we see x over here, we're going to take 2x minus 5 and put it in its place. So we're going to get 2x minus 5 squared, because that's what we do with it here. Whenever we see an x, we're going to put that in its place, minus 3 times 2x minus 5, and then we're going to add 8. We're going to do all the math there, and we end up with 4x squared minus 26x plus 48. So let's do one with actual numbers, b of example 5 there. Slide and go. Okay, so let's take f composite g of 7. Okay, so let's see what we get here. That equals f of g of 7, like that. And that means that whenever I see an x up here, I'm going to put a 7 in its place. So instead of writing f g of 7, I'm going to take this and put 7 in its place. So I'm going to write that as f of 7 squared minus 3 times 7 plus 8. Okay? So that gives me f of 49 minus 21 plus 8, which gives me f of 36. Okay, f of 36 means when I go back up to my f function, whenever I see an x, I put in an x, but this one, whenever I see an x, I'm going to put in a 36 because this is replacing my x. And that will then give me my right answer, which is going to be, let's see, 36, 72, 67. Okay? And if I had g composite f of 7, it would be the same thing. I would just start a little bit differently, and I would put that 7 in here first, and then I would take that answer, which just looking at the book gives me an answer of, looks like 9, and then they put 9 in for this here and get your composite that way, and in this case it's 62. Alright, so let's jump up to example 6, top of page 141. Okay, so there's what we're looking for. We're looking for this composite right here. So I rewrote it as that, and then what I'm going to do is rewrite, continue solving it. So g of x I have right here, and I say that it's equal to that. So I'm just going to replace g of x with x minus 3. And then that says wherever I see an x up here, I'm going to put that in its place. So then that is going to be the square root of x minus 3. And that's what I'm going to get for an answer there. Okay? So the second part of this, B part of example 6 on 141 says to find the domain of F composite G and G composite F. Well, let's just look at the F composite G because it's basically the same thing. The domain of F. Okay, let's look at the domain of F. The domain of F has to be 0 and all positive numbers. So the domain of F has to be the set of all x, sorry about that, such that x is greater than or equal to 0. X cannot be a negative number because it'll give you a negative radical. Or the interval 0, infinity. Okay, 0 and all positive numbers. The domain for G is going to be negative, let's put it over here, negative infinity to positive infinity, right? It can be any real number at all. All right, the composite of FG is this one right here. All right, so what we've got there is the square root of x minus 3, meaning that x can never be a number less than 3, or it'll give me a negative radical. So the domain has to be greater than or equal to 3, right? In order to make that true. So we could write that in interval notation as 3 infinity, or in set builder notation as the set of all x such that x is greater than or equal to 3. Okay, so there is the domain. Okay, so you do the same thing with your G composite F. It's just we didn't find that in this one, so don't worry about that.